Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 22, Chemical Kinetics, Part 4. Here are our objectives for today's video. Pause here. You don't need a ton of detail in the picture. So we talked about some of this in the last video. We're just going to really solidify a lot of the details about the integrated rate laws. So when we're talking about a first order integrated rate law, if I take a plot of natural log of concentration versus time, it will be linear. What we didn't discuss last video, though, is that the slope of that line is just going to be equal to negative k. So this is a useful way to figure out rate constants, and that the y-intercept of that line will be equal to the natural log of the initial concentration. Pause here. You don't need a lot of detail in the picture. If you have a second order integrated rate law, then a plot of 1 over concentration versus time will be linear. The slope of the line is going to be equal to the rate constant, and the y-intercept of the line will be equal to 1 over the initial concentration of the reactant. Pause here. Then if I have a 0th order integrated rate law, a plot of concentration versus time is going to be linear. The slope of the line is just going to be equal to negative k, and the y-intercept will be equal to initial concentration. Pause here. I'll work through this with you. It's really just algebra for this. So all T1/2 is the time required for concentration to be equal to half of initial concentration. So I'm going to rewrite this expression and now all I have to do is solve for KT. Right, so I've got the plus ln of A0 on both sides. So I'm actually going to just remove it on both sides to save myself a little bit of time. I'm going to rewrite this as negative KT is equal to ln of 1 minus ln of 2. If you didn't already know this, the natural log of 1 is just 0. You can put it in your calculator to figure that out, though. So then to solve for T1/2, it's just the natural log of 2 over k. Important to know that the half-life doesn't depend on any concentration. Right, let's take a similar sort of approach to second order reaction. So notice how in the second order that the T1/2 does depend a little bit on concentration. Not a little bit, it does change. So that's just something to keep in mind, that it does affect it. Now let's take a look at the 0th order. So in this expression as well, initial concentration does impact the overall expression for the half-life. That is something that to keep in mind. Pause here. Right, so now we just have a multiple choice question taken from 2008. So it drops to 1/8 of its original value. So 1/8, so 1 divided by 2 is just 0.5. Divided by 2 again is 1/4. And divided by 2 again is 1/8. So that was 3 half-lives. Is equal to 124 seconds. And then the reaction says that it is first order. That means that half-life is constant. So I just take 124 divided by 3. I get 41.3 seconds. So my answer to this is C. Here are the practice problems for today's video. Thank you so much for watching and have a great night.